Hey everyone, I'm Matt Brender. I'm a developer advocate at Intel, and I'm part of the orchestration engineering team in software-defined infrastructure. Which is a ton of terms to say. I play with some open source code lately, and it's been a blast. I want to tell you more about how you get involved in it. So you may have recently known last week was Linux's 25th birthday. Happy birthday, Linux. 25 years from something that was seen as irrelevant when it began to being the #1 operating system for data centers. That is a big deal. And this is hilarious because Linux is all about having to build it yourself. So it took them 25 years to go from being a side project to being something that is run in every data center everywhere for the most part, or anyone that we want to work in. So I want to start simple and say, like, we're going to need to ease our way into open source tooling in our monitoring world. So just sprinkle it on top. Let's not go all the way down to the kernel and start suggesting our default monitoring system is going to be these new architectures that we're not used to yet. But you can start using them on the side and getting greater visibility into what you already do. I showed this in a previous talk as well, that I really see this as a choose your own adventure. There's a ton of tools that you need to mush together or sprinkle together or bake, depending on our analogy, and turn it into something else. All of these are worth looking into, but breaking them into chunks and seeing which piece you need to talk to which other piece is important in my opinion. So I always start with telemetry. It's what I've been talking a lot about, but let's differentiate that from other things. So telemetry is the stuff you can measure and the process by which we capture it. I tend to see that as 3 phases: the collection, processing, and publishing of that information. So you're both sensing it and also determining the way by which you push it somewhere else. And that telemetry is good to separate from metrics, which metrics are just the facts of the data center. The telemetry is both the process and the sensing of it. And analytics is a totally different beast. Analytics is the analysis of that information. It's making a decision. It's is this good or bad? Is this positive or negative? Is this change or normal? So we're going to need all 3 of these pieces, but they're not all the same thing. So if we take a practical example, like we need to just basically see if our application's alive, we'd probably use ping. Or if we can talk to the world. If we want to look a little at our operating system, you might use a very common package called psutil. And if you want to look at your hardware utilization, you might use an Intel Performance Counter, PCM. But it doesn't tell you the why. The why is because we have SLAs we have to be compliant to. We have system performance that we have to keep within a range as well. And predicting our hardware usage is huge to knowing if we need more servers in the near future. So here's where I get into my thought leadership part of this. I want to tell you a little bit of a framework by which I'm understanding the different parts of monitoring. And hopefully this will be a way for you to grasp the different tools. But I'm going to stick with a little thought leadery logo so you know that this is not an official opinion of anyone but me. So monitoring is this big blob. It's a lot of different pieces that I see break out into these chunks. Logging, the unstructured portion of that information, is complemented by telemetry, the collection of the metrics of the system and publishing of it. You only want logging and telemetry if you're going to end up pushing it somewhere and you're pushing it into some persistence layer. So you have some sort of database or some sort of message queue that end up landing in a database, so you always have a database. And then ultimately, you're also going to have requirements around that. You're going to have requirements of escalation, because guess what? We have to keep these things online. So there are notifications and alerting architectures out there that are extremely important to day-to-day operations and to pagers and who's on call. And then you have the visualization, which we were talking about before, like Fauna as a great example. And then learning, there's a whole pipeline of information we can do about learning. And that, by learning, I mean everything from the touching, just sprinkling a little statistics on top of things, to doing a real analytical deep dive and machine learning algorithm and anomaly detection and all that stuff. We talked about telemetry a little bit. If we zoom in on just telemetry, it has its own pieces. We have the collection, processing, and publishing of things. We have the schedule by which you're collecting that information and the mechanism by which it is actually collected. And then there's some sort of automation around it as well, which I really think is crucial at this step for scale. So when we take a step back out, all of these other pieces have just as many nuances that truly I don't understand yet. I'm digging in one piece at a time, but I found that these are the chunks of the sphere that I need to understand in order to know what we're talking about when you say you do or don't monitor your infrastructure. Snap is that tool I've been talking about a lot. And Snap fits only in that one bubble. You're only going to get the telemetry part. So the question is, where's the rest of your pipeline? Grafana, a tool I really admire for visualization. They have some new notification features coming out in their V4. They have some basic statistics information you can use out of the box. And I believe they're adding alerting alongside the notifications. So they're growing in scope, but even they require a separate persistence model and a separate telemetry and logging model. They're really incredible detailed architectures if you're interested in understanding the principles of strong monitoring. These two in particular, one by Obscurify, who's a really thoughtful guy who wrote the book on Graphite, who talks about like each of the pieces from sensing to all the way to when he says notifier, it's actually the person that's on call to go get notified about that information. And then another guy from Google, Kasky, gave an excellent talk 4 years ago now, that goes through these different portions of what he thinks is the definition of monitoring. So I'm starting to aggregate these together in a GitHub repo called What We Talk About When We Talk About Telemetry. And I hope you'll contribute to it as you start to learn things and figure out what we should value. So I have some rhetorical questions for you. Do you need telemetry? What does that even mean? Well, some people say, like, I don't need that. I have Graphite. Graphite's an open source tool that's really cool that you guys should check out, but let's take a look at what Graphite is in my weird blobby diagram of monitoring. It persists information. It has a very simple visualizer, very simple notification system, and also has some statistics to it. So do you still need telemetry? The answer is yes. You haven't scratched that surface yet. Normally when you're using Graphite, you're actually using collectd or daemon for a Python system and pushing that into Graphite. But the fact that you don't know that when you're using just Graphite is already part of the challenge that you have ahead of you, which is why it's important to understand all the bubbles. And when you're thinking about monitoring, you're like, well, no, we're good on monitoring. I've got Nagios. Nagios is a very well-respected open source tool. It's been used for years, but it does a very simple amount of visualization and notifications, and it doesn't persist any of that information. So while it's handy, it's, again, not the full picture. So if we look back at what telemetry is, just to remind you of this one piece of the puzzle that I understand, if it breaks out into the chunks that I showed you, there's a collection, processing, and publishing for data normalization and for persisting onto different endpoints that you want for that persistence. And then you ultimately only care about that if you can visualize it. So I want to fill those boxes with those two tools that we've been talking about, Snap and Grafana. But that still means I need to understand the persistence layer, which is where I've really been digging into Prometheus, which I'd highly recommend checking out. And it's been actually taken over by the Cloud Native Computing Foundation as their core monitoring framework. Has a really, really slick syntax language and spins up in 10 seconds on your laptop because it just pops up on Docker. So checking out Prometheus alongside these tools would be very powerful if you're looking to get more into monitoring. And if you like hacking around in Go, you can actually go build these tools. All three of the ones I'm talking about are primarily written in Go. And there's a lot of JavaScript stuff on the Grafana side if you're into that. And if you are, please go help. It's always nice to have prettier pictures. But yeah, I just want to give you that little intro. So if you take anything away from it, Snap, Grafana, and Prometheus are all great tools to check out. And I hope to talk more about monitoring your infrastructure and how you can sprinkle a little into your existing data center. Feel free to reach out in any of these places. Thanks.